Part B. An additional object of mass m kilograms is attached at point A so that the rod is on the point of turning about y. Calculate the value of m. Okay, so if something is attached or removed, you need to redraw your picture. Okay, don't try and adapt what you've already got. Okay, let's just start again. So point A is this end, so we've got an extra mass of m kilograms, so I'm going to put mg there. Okay, we've got our support at x, we've got our support at y, we've got our midpoint at 5g, we've got our 11g at the end. Okay, we've still got exactly the same distances. Okay, so this is our situation. The x and the y are now totally different, so you don't use any answers from part A at all. Okay, as soon as you add more mass or take away, then everything will change. Okay, so what we have to think about here now is if we're at the point of turning about y, or tipping, sometimes they'll say. Okay, so here's point y. If we're about to tip, okay, we're not going to be able to tip that way because support x is in the way. And remember, we've just put a heavy mass on this end, presumably, which is going to make it tip that way. Okay, it certainly could tip that way. Support x is sort of redundant at that point, isn't it? So if it's going to tip in that direction, as I'm showing you with the pen, okay, it's basically just going to turn into a seesaw question, okay, with y as the pivot of the seesaw. Okay, so think of this as support y, 5g there, 11g there, mg there. Support x is not needed if it's going to tip downwards, is it? So it's just basically working out if it's just on the point of tipping but it hasn't moved, you've basically put exactly the mass that would make it be perfectly balanced if you remove support x from the picture. Okay, so you want to say if this mass balances these two, again we can take the y as the pivot, okay, and do our moments equation with point y as our pivot. Okay, there is a force upwards, but we're not working that out. Okay, so we need to say the turning effect of this mg would be distance times force, so 0.9 times mg. That's the force that's making it tip that way. Okay, and that's being balanced by the turning effect of the 5g and 11g that are still trying to make it tip the other way. So make sure you're using the correct distance from the pivot each time. Oh no, that's 11g. So 0.9 times mg is equal to 0.3 times 5g, add 1.5 times 11g. Okay, I can actually cancel out g, so that makes it nicer. So I end up with 0.9 m is equal to, let's work out 0.3 times 5, add 1.5 times 11, 18. Divide that by 0.9 and we get 20. Okay, that would be 20 kilograms. M is measured in kilograms. So our answer is 20 kilograms.